came so easy when I wrote this. Reason they hate so hard. Man, trade call cause the handle fell off. And separate weak.
So sometimes when we're trying to find that area between the two curves, we have to divide the region up. So in the case that we have to divide the region up. Because let's say we have some graphs that look like this. So here's our x and y. This is our f of x function, let's say. So this is f of x, and then here's our g of x. It'll come like this, let's say. So this is our g of x. And we want to evaluate from a to c. Okay? A to c. That's what we want to find the area between the two curves. But as we see here, we can't use the same exact formula for the entire interval because if we look at this region here, our g of x function is on the bottom, right? G of x is down here and f of x is on the top. And for this interval though, then our g of x goes to the top and our f of x is on the bottom. So what we have to do is divide the region up, aka break it up by addition signs, okay? So what I like to do is break up the info according to intervals. So let's say this point right here is b on the x-axis, okay? So our subinterval here, the first one is AB, and this second interval is BC, okay? I'll actually write that one a little bit further to the right so we can have more room. So this second one is BC, all right? So let's look at AB interval first. So which one is on the top? We see our top function actually being the f of x, right? So this is f of x up here, and on the bottom is our g of x. So top is f of x, okay? And bottom is g of x then, all right? And then for the next subinterval, B to C, we have g of x is the top function, so g of x, and the bottom function is our f of x, okay? So top is then g of x, and the bottom, b, is our f of x, okay? So then what we're going to do is actually make use of the fact that these two intervals here, they are adjacent intervals. So that means they are able to be added together, the integrals are, right? So these two areas here, they can be separately calculated and then added together to get the entire interval over, or the entire integral over the interval a to c, okay? So let's keep these in mind, these things at the bottom here, and we'll continue this on the next slide. So our area, our total area, is actually going to be given by, so instead of saying something, well, we're going to say from A to B, so this is our first subinterval, right? And then we have top minus bottom. So in this case, top was f of x and bottom was g of x, all right? So this was the area, this is the area of the first region, area of left region, we'll call it, okay? And then we're going to add that to the area from B to C of that second region. So this, in this case, the g of x was on top, right? So top minus bottom is now g of x minus f of x. So this is the area of the right-hand region, all right? And this is going to be basically the total area over the interval a to c. All right, so here's a review of what we've been doing. It's called integration along the, integration along the x-axis, right? Along the x-axis, the x-axis, there we go. So some properties of this, because I'll compare it to another kind of integration that we're going to learn. So the properties of the one that we've been doing is it looks something like this. So we have our x and our y. Here's our function. So we have an f of x, and a g of x there. Okay, and we have our a and b, which are on the x-axis, right? So our area looks something like this. Okay, so some properties of this are that the formula itself is the area is equal to the integral from a to b of y top minus y bottom. So that means our y's are functions of x, okay? So this is top and bottom. So we have top and bottom here. We have this dx, okay, because our differential, that means we're moving along the x-axis. Our interval is from a to b, which is also along the x-axis. That's an x interval that shows us how far left and how far right we're going to go. We do have vertical lines here, right? So vertical lines, here I'm just listing some of the characteristics of integrating along the x-axis, okay? So we have vertical lines, and our y is equal to an f of x, which is a function of x, and g of x, which is a function of x, okay? So that's pretty much it. Those are all the characteristics of integrating along the x-axis. Now what we're going to learn is how to integrate. So integration along the y-axis, along the y-axis. And everything is basically going to be turned on its side, literally. So what that means is that our graph is now going to look like x and y. So now we have, instead of curves going like horizontally sort of, we're going to have them going a little bit vertically, okay? So we have something like this. So this one I'll call g of y, and this one is our f of y, okay? And then instead of integrating on the x-axis, so our interval, instead of it being from a to b on the x-axis, it's going to be like a c to d, I'll just call it c to d on the y-axis. So that means we're our intervals are like actually denoted by horizontal lines, right? So now we're going to find the area between these two curves, our f of y and g of y. So here, instead of, like I said, we have horizontal lines, and I'll actually write that down so we can compare it with vertical lines. So we have horizontal lines, and instead of top and bottom, now we have a right-hand function, which is f of y in this case, and a left-hand function. So we have a right and a left instead, okay? So, and we also, again, we have our dy instead of dx, because now the change in the lines that we draw are on the y-axis, okay? That's where we are varying the variable, okay? And our interval is from c to d, and this is along the, this is a y interval, okay? This is how much we go up and how much we come down. C is the lower limit and d is the upper limit, okay? And then we also have these functions are x functions, so x alone, and it's a function of y, and a function, another function of y. Okay, so our overall area formula is actually going to look like, if we put all of this together, it's the integral from c to d in this case. Sorry, it's kind of small in here, but the integral from c to d of x right, so x, the right function, minus x left, okay, and then we have a dy instead. Alright, so we're going to take this formula and extend it to an example on the next problem.
I treasure being the voice of the children of a lesson. God gon' test you. You gotta survive when he apply the pressure and give you a shock like a lie detector. Where were you when they was passing?